QSFP28 100G LR4 and QSFP28 Single Lambda 100G LR both have LR in their names, which stands for long reach, meaning they both support transmission distances of up to 10 kilometers. Their interfaces are both duplex LC, and they both use single-mode fiber. At first glance, they may seem the same, but in fact, these two modules are fundamentally different in core technology. In this video, we will explain the differences clearly. Let's first take a look at the 100G QSFP28 LR4 module. It is a very mature and widely used 100G long-reach module, utilizing four wavelengths: 1295 nanometers, 1300 nanometers, 1304 nanometers, and 1309 nanometers. It uses NRZ modulation technology, converting four 25 gigabits per second electrical signals into four optical signals, which are then combined onto a single fiber through wavelength division multiplexing. At the receiving end, the signals are demultiplexed back into four separate electrical signals. The Single Lambda QSFP28 100G LR module follows a completely different technical approach. It typically operates at a wavelength of 1310 nanometers and no longer uses four wavelengths, instead achieving 100G transmission directly over a single wavelength. The key here is that it employs PAM4 modulation. Since only a single wavelength is used, there is no need for multiplexing or demultiplexing, making the optical structure simpler. However, this also places higher demands on signal processing capabilities. After introducing the differences between the two modules, let's move on to a very practical question. How should you choose between them? First, consider your performance requirements. Although both modules support 10 kilometers transmission, their technical approaches are completely different. LR4 uses NRZ and multi-wavelength transmission, making it more mature and offering advantages in stability and error rate control. In contrast, Single Lambda LR uses PAM4, making it better suited for high-density data centers and other scenarios where bandwidth efficiency is a priority. Next, consider device compatibility. You need to verify whether your existing equipment, such as switches and media converters, supports the specific type of optical module, including the interface type, data rate, and modulation method, to ensure proper interoperability. Finally, when making a choice, cost and future scalability are equally important. You should consider the overall expenses of each module, including initial purchase costs and long-term operational costs, and evaluate potential future upgrade requirements and associated expenses. Additionally, pay attention to the solution's scalability. For example, 100G LR supports 400G to 100G breakout connectivity, providing flexibility and assurance for long-term network planning. That's all for this video. If you found it helpful, please like and subscribe to our channel.